So we have a spider web that is being stressed, and we read that when a load is applied to a material, it is said to endure stress. The magnitude P of the stress is given by F over A, where A is the cross-sectional area of the sample material. Use the graph of the data below to deduce the thread used in the experiment, to deduce that the thread in the experiment does have a greater stress than steel. So we need to use our graph, and the data below is greater than the breaking stress of steel. So we have P equals F over A. And the area, we're told, is the cross-sectional area. We have the radius, and so that's going to be pi r squared. Pi r squared. And the force, a greater breaking strength than the spider web. Well, we look here, it breaks at this point. And that force, when we read it off the graph, looks to be about 8.5. And remember, this goes by, these numbers are 0.09, 0.08, and so this goes by 0.002. And so that's about 0.085. 0.085 newtons over pi, and the radius of the thread is 4.5 times 10 to the minus 6th, and that's squared. .085 divided by pi times 10 to the minus 6th. And that whole denominator needs to be squared over squared. Gives us an answer of 1.336 times 10 to the 9th newtons per meter squared. Whereas steel, so this is the web, and steel is 1.0 times 10 to the 9th newtons per meter squared. So we can see that the spider web does have a greater breaking stress than steel. In fact, 33% higher. So we would say since P web is greater than P steel, the spider web has a greater breaking stress. And that is part B.